Somewhere in the Sicilian countryside, late July 1943, a German signals officer stood over a piece of American equipment his patrol had just pulled from an abandoned foxhole. The green metal backpack radio was still intact, battery connected, antenna bent but unbroken. He'd seen captured equipment before. British wireless sets from North Africa. French relics from 1940. Standard procedure. Document it. Test it if possible. File a report. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. But when he switched the device on and listened through the handset, something stopped him cold. The radio was receiving an American transmission from somewhere beyond the next ridgeline. What he heard wasn't the tinny, static-choked voice he expected from field radios. It was clear, crystal clear, as if the American operator was standing 3 feet away instead of miles across hostile territory. No crackling, no hiss, no interference from the dozens of vehicle engines, generators, and electrical equipment that should have been drowning out every signal for kilometers around. The German officer, trained in radio communication since the 1930s, understood immediately that he was holding something fundamentally different. This wasn't just another radio. This was evidence of a technology gap that was quietly reshaping the battlefield in ways Berlin hadn't fully grasped. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. You might think this is just another story about Allied material superiority. More equipment, more resources, more of everything. But the SCR-300 radio represented something deeper than logistics. It represented a philosophical divide about how modern warfare would be conducted. The Americans had built their infantry radio around frequency modulation, a technology that German engineers understood in theory but had dismissed as impractical for field use. That decision, made in peacetime laboratories and planning offices, was now costing German forces something they couldn't afford to lose. Battlefield coordination. German radio doctrine in 1943 still relied on amplitude modulation, the same basic technology that powered civilian broadcast stations. Their standard infantry sets, the Tornister series, were engineered with typical German precision. The Torn Fu D2 operated in the 33 to 38 MHz range, 1.5 watts output, effective range of 3 kilometers for voice transmission, 10 kilometers for Morse code under ideal conditions. These were proven, reliable radios, but they all shared the same fundamental vulnerability. Amplitude modulation carries information by varying the strength of the radio signal, and anything that affects signal strength, static from thunderstorms, electrical interference from vehicle engines, even the spark plugs of a motorcycle passing nearby, corrupted the transmission. German field commanders in Sicily had been reporting communication problems for weeks. Radios that worked perfectly during training exercises in Germany degraded rapidly under combat conditions. The dense concentration of vehicles, generators, and electrical equipment that accompanied mechanized warfare created a fog of interference that made amplitude modulation radios increasingly unreliable. Forward observers struggling to adjust artillery fire. Company commanders losing contact with battalion headquarters during critical moments. Platoon leaders unable to coordinate maneuvers when scattered by Allied attacks. These weren't equipment failures in the traditional sense. The radios functioned exactly as designed. The problem was that the design itself belonged to a different era of warfare. The context matters here. By mid-1943, the Wehrmacht was fighting battles of unprecedented complexity. Combined arms operations across North Africa, the Eastern Front, and now Italy demanded constant radio communication at every level. Artillery needed real-time corrections from forward observers. Tank formations needed to coordinate with infantry. Air support required ground controllers who could talk to pilots overhead. Every broken transmission, every request lost to static, every order that arrived garbled after 3 attempts, multiplied across thousands of units. The cumulative effect was a command system that worked beautifully on paper, but fractured under the chaos of actual combat. And meanwhile, American infantry units were operating with a radio that seemed immune to the very problems plaguing German communications. The SCR-300 had entered American service in 1942, developed by the Galvin Manufacturing Company, later known as Motorola. The project began in 1940, when the Army Signal Corps approached the company with a challenging specification. They wanted a portable, battery-powered radio that infantry could carry into combat. It needed to work in any weather condition, operate reliably near electrical equipment, and provide clear voice communication over at least 3 miles. The engineering team, led by Daniel Noble with principal RF engineer Henrik Magnoski, made a decision that would prove revolutionary. Instead of using conventional amplitude modulation, they built the radio around frequency modulation. FM technology had been proven in theory by Edwin Armstrong in the 1930s, but it remained largely experimental in military applications. Most radio engineers considered it too complex, too power-hungry, too temperamental for battlefield use. Noble's team proved them wrong. The SCR-300 design used frequency modulation in the 40 to 48 MHz range. Instead of varying signal strength like AM radios, it varied signal frequency. This single change made the radio nearly immune to the interference that plagued amplitude modulation. Static affected signal amplitude, but FM receivers ignored amplitude variations entirely. They only responded to frequency changes, which carried the actual voice information. The technical advantages were measurable. The SCR-300's frequency modulation system provided approximately 25 decibels, better signal-to-noise ratio compared to comparable AM radios. In practical terms, this meant that an FM transmission remained intelligible even when background noise was 100 times stronger than it would need to be to drown out an AM transmission. The radio also incorporated features that German field radios lacked, an automatic squelch circuit that eliminated the constant background hiss when no one was transmitting. Automatic frequency control that kept the radio locked on channel even as components heated, up during operation. A crystal-controlled calibration system that allowed operators to verify their frequency was accurate. 40 separate channels instead of the limited channel selection available on German sets, but the real breakthrough was reliability under field conditions. The SCR-300 could operate next to running tank engines without losing clarity. It worked through electrical storms that rendered AM radios useless. The antenna, a 10-foot sectional whip, was longer than necessary for the frequency range, but the extra length ensured solid performance even when damaged or partially retracted. The first combat test came in August 1943 in New Georgia, part of the Solomon Islands campaign in the Pacific. Colonel Ankenbrandt reported to General Meade that the SCR-300 was exactly what was needed for frontline communications in jungle terrain. The radio maintained clear transmissions through dense vegetation that would have absorbed or distorted AM signals. The only significant problem was battery supply. The 18 vacuum tubes consumed power steadily, giving the BA-70 battery pack about 25 hours of operation. By the time of the Sicily invasion in July 1943, enough SCR-300s had reached infantry units to make a tactical difference. American battalion commanders could coordinate company movements in real time. Forward observers could walk artillery fire onto targets with continuous radio contact. Platoon leaders maintained communication even when spread across kilometers of rough terrain. The radio worked exactly as designed, under conditions that stressed German AM radios to failure. German signals intelligence officers monitoring Allied transmissions noticed the quality immediately. American radio communications were markedly clearer than British transmissions, which still used primarily AM equipment. German radio intercept stations could hear American operators communicating with casual clarity, as if interference didn't exist for them, which, effectively, it didn't. Captured SCR-300s began appearing in German technical intelligence reports by late summer 1943. The standard evaluation process sent interesting equipment back to Germany for detailed testing. The radios that survived capture generally reached signals testing facilities where German engineers could examine them thoroughly. These evaluations documented the obvious external features: the split battery configuration that allowed weight distribution across the operator's back, the waterproofed case with rubber grommets that sealed against moisture, the rugged construction that survived field use. But the internal examination revealed something more significant. The 18-tube design was conventional superheterodyne architecture, nothing revolutionary about the circuit topology. What made it work was the frequency modulation system. German engineers understood FM theory perfectly well. Their own radio development programs had explored frequency modulation in the 1930s. They'd concluded it wasn't practical for military field radios. The reasoning seemed sound at the time. FM required wider frequency spacing between channels to avoid interference. This meant fewer possible radio nets in a given frequency band. FM transmitters were more complex than AM transmitters, requiring more tubes and more precise engineering. FM receivers needed careful design to properly demodulate the signal, and perhaps most importantly, FM performed poorly over very long ranges compared to AM on the same frequency. All of these factors mattered in the context of German military planning during the 1930s. Germany was preparing for mobile warfare across vast distances. Long-range communication between headquarters and forward units seemed more important than short-range tactical communication between infantry squads. The complexity and cost of FM systems seemed unjustified for portable radios that would be issued to every company. So German military radio development focused on amplitude modulation, building progressively better AM radios with improved sensitivity and selectivity. By 1940, they had sophisticated equipment like the Torn Fu series. These radios worked. They fulfilled their design specifications. They just weren't designed for the kind of warfare that actually emerged. The Americans approached the problem differently. Their radio development in the late 1930s and early 1940s wasn't constrained by existing doctrine. They were building a mass army from scratch, with no established traditions about how infantry communications should work. The signal corps specifications for the SCR-300 emphasized tactical coordination at company and battalion level, not strategic communication across hundreds of kilometers. This shifted the priority from maximum range to maximum reliability. FM's advantages: immunity to interference, clear audio quality, resistance to signal fading, mattered more than its disadvantages for short-range tactical work. The wider channel spacing wasn't a problem when you only needed 40 channels. The complexity was manageable with American manufacturing capability. The shorter maximum range wasn't relevant when you were trying to coordinate infantry companies a few kilometers apart. By 1943, these different design philosophies had produced radios optimized for completely different tasks. The German Torn Fu D2 was excellent for what it was designed to do: provide reliable communication over moderate distances using proven technology. The SCR-300 was excellent for its intended purpose: enable clear tactical coordination under the electrical and atmospheric conditions of modern mechanized warfare. The problem for Germany was that the battlefield had evolved toward the American model. Modern combat, especially the Wehrmacht, combined arms operations that dominated 1943 and 1944, required constant short-range coordination more than occasional long-range communication. Infantry needed to talk to tanks moving with them. Forward observers needed continuous contact with artillery batteries. Company commanders needed to adjust plans moment by moment as situations changed. All of this worked better with FM. German units trying to coordinate similar operations with AM radios found themselves at a systematic disadvantage. Not a catastrophic failure, the Torn Fu sets worked well enough to maintain basic communications, but a steady degradation of effectiveness. Orders took longer to transmit, corrections required multiple attempts. Time-critical coordination often failed because static or interference garbled the crucial first transmission. The Sicily campaign demonstrated this dynamic clearly. American infantry units advancing across difficult terrain maintained better command, cohesion than German defenders with comparable training and experience. When American forward observers called for artillery support, corrections arrived quickly and accurately. When German observers attempted the same, interference forced repeated transmissions that gave American units time to displace or take cover. None of this was immediately obvious to either side. The Americans didn't fully understand why their radios worked so much better. They just knew the SCR-300 was reliable and clear. The Germans recognized that American communications seemed more effective, but attributed it to having more radios, better training, or favorable terrain. The technical root cause, the fundamental difference between FM and AM under field conditions, remained underappreciated. German radio development programs in 1943 and 1944 attempted improvements. They designed new Torn series variants with better selectivity to resist interference. They developed training programs emphasizing proper radio procedure to minimize transmission length. They experimented with power increases to override ambient noise. All of these helped marginally. None addressed the core problem, that amplitude modulation was inherently vulnerable to the electromagnetic environment of modern warfare. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. By late 1944, German signals officers had clear evidence that Allied radio communications worked better than their own. Intercept reports consistently noted the superior clarity of American and British FM transmissions. After-action reports from unit commanders mentioned difficulties maintaining radio contact during critical operations. Technical evaluations of captured equipment documented the FM advantage in detail, but Germany lacked the industrial capacity and time to redesign and manufacture an entirely new generation of infantry radios. The existing Torn series radios remained in production and service through the end of the war. They continued to work. They continued to provide adequate communications under favorable conditions. They just couldn't match the reliability and clarity of FM equipment under the conditions that actually existed on World War II battlefields. And that gap, measured in garbled transmissions and delayed orders, contributed to the cumulative erosion of German tactical effectiveness across every front. The technical gap between FM and AM radios manifested most dramatically during the Normandy invasion and the subsequent campaign across France. By June 1944, American infantry units were equipped with thousands of SCR-300s. Every battalion had multiple sets. Many companies had at least one. The radios had become as essential to American infantry operations as rifles and ammunition. The morning of June 6, 1944, demonstrated exactly why. Airborne units scattered across Normandy behind German lines used SCR-300s to coordinate assembly and attacks despite being miles from their intended drop zones. The radios worked through the fog and darkness that grounded observation aircraft. They maintained contact through the electromagnetic chaos of thousands of vehicles, generators, and electrical systems operating simultaneously across the beachhead. German defenders, meanwhile, struggled with radio communications degraded by the very conditions that made the invasion possible. The overcast weather that hid the Allied fleet from observation also generated atmospheric interference that plagued AM radios. The massive concentration of Allied vehicles and equipment created an electromagnetic environment that made German tactical radios increasingly unreliable. Forward observers with American units could call artillery corrections in real time, adjusting fire mission by mission as German positions revealed themselves. German observers attempting similar coordination found their transmissions frequently garbled by static and interference, forcing repeated attempts that consumed precious time and often arrived too late to be useful. The Battle of the Bulge in December 1944 provided perhaps the clearest demonstration of FM radio's tactical value. When German forces launched their surprise offensive through the Ardennes on December 16th, American units found themselves scattered, surrounded, and fighting in terrible weather. Winter storms generated severe atmospheric interference. The massive movement of tanks and vehicles on both sides created electromagnetic noise across the battlefield. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Under these conditions, traditional AM radios would have been nearly useless. But the SCR-300 maintained clear communications through weather that would have silenced amplitude modulation sets. Isolated American units maintained contact with headquarters. Artillery observers continued directing fire support. Company commanders coordinated defenses even when surrounded. Historical accounts specifically credit the SCR-300 as key equipment that helped prevent confusion during the battle. When German attackers succeeded in cutting communications lines and isolating American units, radio became the only reliable means of coordination. The clarity and reliability of FM transmissions under winter storm conditions proved decisive in maintaining command cohesion during the most chaotic phase of the battle. German forces attacking through the Ardennes relied on their standard Torn series radios. These worked adequately under favorable conditions, but the combination of winter weather, heavy vehicle concentration, and the electromagnetic interference of modern warfare degraded their effectiveness precisely when reliability mattered most. German commanders later reported difficulties maintaining radio contact during critical operations, forcing greater reliance on motorcycle couriers and landlines that were slower and more vulnerable to disruption. The man whose invention made this possible never sought recognition for his contribution to the war effort. Edwin Howard Armstrong, who had developed frequency modulation in the 1930s, freely offered his FM patents to the US Army during World War II. He asked for no royalties, no payment, no acknowledgement beyond knowing his work helped Allied forces communicate more effectively. Armstrong had served in the Signal Corps during World War I, where he invented the super-heterodyne circuit that became fundamental to modern radio receivers. After the war, he returned to Columbia University and spent years researching the problem of radio static. By 1933, he'd developed wideband frequency modulation, a completely new approach to radio transmission that made static-free broadcasting possible. The civilian radio industry initially resisted FM. It required different transmitters and receivers. It meant abandoning the massive infrastructure investment in AM broadcasting. Corporate giants like RCA, led by David Sarnoff, actively opposed FM development, seeing it as a threat to their AM broadcasting empire. Armstrong built his own FM station in Alpine, New Jersey in 1939, using his own money to prove the technology worked. When war came, the Army Signal Corps recognized FM's potential for military communications. They approached Armstrong, who immediately made his patents available without charge. The SCR-300, along with tank radios like the SCR-508 and artillery sets like the SCR-608, all used Armstrong's FM technology. These radios gave American forces a communications advantage that couldn't be measured in tanks or artillery pieces, but proved equally valuable in combat. Armstrong never profited from his wartime contribution. After the war, he spent years fighting legal battles over FM patents, eventually exhausting his fortune in litigation against companies that had infringed on his work. In 1954, depressed by legal defeats and financial ruin, he took his own life. His widow Marion continued the patent battles and eventually won recognition for Edwin as the true inventor of FM radio. But Armstrong never lived to see frequency modulation become the dominant technology for high-quality broadcasting and military communications worldwide. The irony cuts deep. The technology that gave Allied forces clear, reliable battlefield communications that helped coordinate artillery strikes and maintain command cohesion through the worst weather and heaviest fighting of World War II, bankrupted its inventor through patent litigation. Armstrong understood better than anyone that FM represented the future of radio communications. He just happened to be on the wrong side of corporate power during the transition. German engineers, examining captured American radios after the war, fully understood what they'd been facing. Post-war technical assessments acknowledged that FM provided significant advantages over AM for tactical communications. German radio development programs had explored frequency modulation in the 1930s, just as American programs had. But Germany made different choices about which technology to pursue, based on different assumptions about how modern warfare would develop. Those assumptions, formed during peacetime planning, proved less accurate than the reality of World War II combat. The battles of 1943 through 1945 weren't fought across vast open spaces where long-range AM radio excelled. They were fought in the electromagnetic chaos of mechanized warfare, where short-range FM radio's immunity to interference provided decisive tactical advantages. The British recognized this quickly. They adopted the SCR-300 design after the war as their wireless set number 31, using it well into the 1950s. The Soviet Union, which received some American FM radios through Lend-Lease, incorporated similar principles into post-war radio development. NATO standardization agreements explicitly required FM capability for tactical radios, establishing Armstrong's technology as the foundation for Cold War military communications. The United States continued using the SCR-300 through the Korean War. During defensive battles like Cheopyeong-ni in February 1951, American units maintained radio communication through conditions that would have silenced less robust equipment. The radio proved its value in Vietnam, where jungle terrain and tropical weather created challenging conditions for any communications system. The SCR-300's basic design remained in U.S. Army inventory until the 1990s, and remarkably long service life for equipment developed in the early 1940s. Modern military radios are digital, encrypted, and vastly more sophisticated than the SCR-300. But they all use frequency modulation for the same fundamental reason Armstrong identified in the 1930s. FM provides superior resistance to interference and better audio quality under field conditions than amplitude modulation. The technology that gave American infantry clear communications in Sicily and Normandy and the Ardennes remains the foundation of tactical radio worldwide. The German Torn series radios that opposed them were well-engineered equipment built to high standards. They fulfilled their design specifications admirably, but they were designed to solve the problems German planners anticipated in the late 1930s, not the problems that actually emerged during World War II. That gap between peacetime assumptions and wartime reality created a systematic communications disadvantage that German forces never fully overcame. Modern military historians studying World War II communications note the compounding effects of small tactical advantages. A German company commander who needed 3 transmission attempts to coordinate with battalion headquarters lost minutes that could have been used for actual coordination. An American company commander whose transmission went through clearly on the first attempt gained those minutes for planning and execution. Multiply this across thousands of units and hundreds of operations, and the cumulative effect becomes significant. Battlefield coordination requires more than just having radios. It requires radios that work reliably under the conditions that actually exist in combat: weather, terrain, electrical interference, enemy jamming, equipment damage, operator fatigue, all degrade communications. The side whose radios maintain effectiveness despite these challenges gains an advantage in the continuous struggle to coordinate forces faster and more effectively than the enemy. FM radio didn't win World War II. No single technology did, but it contributed to Allied tactical superiority in the same way that reliable logistics, effective artillery coordination, and air superiority did. It was one piece of a larger system that gave Allied forces consistent advantages in executing combined arms operations. German units fighting against American forces noted repeatedly that Allied coordination seemed more responsive, more flexible, more effective. Part of that perception came from communications equipment that simply worked better under field conditions. The broader lesson extends beyond World War II. Technological advantage in warfare often comes not from revolutionary breakthroughs, but from systematic attention to reliability under actual operating conditions. The SCR-300 wasn't dramatically more advanced than German radios of any single specification. Its frequency range was similar, its power output was comparable, its weight and battery life were unremarkable. What made it superior was that it kept working when other radios failed. In thunderstorms, near running tank engines, during artillery barrages, in dense terrain, under extreme temperatures. The radio maintained clear communications because its fundamental design, frequency modulation, was inherently more robust than amplitude modulation in the electromagnetic environment of modern warfare. German engineers understood this after examining captured equipment, but understanding came too late to matter. By the time Germany could have designed, tested, and manufactured an entirely new generation of FM radios, the war was effectively lost. Industrial capacity had shifted to desperate production of basic weapons and ammunition. Resources weren't available for major radio system redesigns. The Torn series radios continued in service, performing adequately but never matching the reliability of Allied FM equipment. The German officer who listened to that clear American transmission through the captured SCR-300 in Sicily back in July 1943 was hearing the sound of technological obsolescence. His own radio training, his doctrine, his equipment, all reflected choices made years earlier based on assumptions that proved incomplete. The Americans had made different choices, built different equipment, adopted a different technology, and in the grinding attrition of mechanized warfare, those differences accumulated into advantages that couldn't be overcome through skill or determination alone. That's perhaps the cruelest aspect of technological warfare. Superior equipment doesn't guarantee victory, but inferior equipment guarantees disadvantage. The German soldier carrying a Torn Fu Day 2 radio into battle wasn't equipped with bad technology. He was equipped with technology designed for a different war than the one he was actually fighting. And that mismatch, repeated across thousands of units and millions of transmissions, contributed to the steady erosion of German tactical effectiveness across every front. The legacy of Armstrong's FM radio extends far beyond World War II. Every modern communications system, from broadcast radio to cellular networks to military tactical radios, uses principles Armstrong developed. The superheterodyne receiver he invented during World War I remains fundamental to radio design. The frequency modulation system he perfected in the 1930s became the standard for high-quality audio transmission worldwide. But Armstrong himself gained little from these contributions. He spent his fortune fighting legal battles to protect his patents. He died believing his life's work had been stolen by corporations, more interested in protecting existing investments than advancing radio technology. His widow Marion spent 13 years in additional litigation before finally winning recognition that Edwin Armstrong was the true inventor of FM radio. The SCR-300 radio that gave American infantry clear communications through the worst conditions of World War II stands as Armstrong's most important military contribution. Not because of its technical specifications or its production numbers, but because it demonstrated that fundamental design decisions, made years before war began, could create persistent tactical advantages throughout an entire conflict. The choice between AM and FM, made in laboratories and planning offices during peacetime, determined whose radios would work reliably when it mattered most. Germany entered World War II with well-engineered amplitude modulation radios built to exacting standards. America entered with frequency modulation radios designed around different principles. By 1945, it was clear which approach better suited modern mechanized warfare. But by then, the question was settled not by engineering debates but by battlefield results. And on battlefields from Sicily to Normandy to the Ardennes, American radios maintained communications when German radios struggled with interference and static. The lessons learned from the SCR-300's performance in World War II didn't fade with victory in 1945. They fundamentally shaped how every modern military approached tactical communications. The radio that had given American infantry clear voices through Sicilian summers and Ardennes winters became the template for a revolution in battlefield coordination that continues today. By the early 1960s, a new generation of FM radios was entering service with U.S. forces. The AN, PRC-25, developed in the late 1950s as a replacement for Korean War-era equipment, incorporated solid-state circuitry that made it lighter and more reliable than its vacuum tube predecessors. The Prick 25, as soldiers universally called it, weighed about 23 pounds with batteries, roughly one-third lighter than the SCR-300. But the fundamental technology remained Armstrong's frequency modulation. The PRC-25 operated in the 30 to 76 MHz VHF band using FM transmission. It featured an improved squelch circuit that muted background noise even more effectively than the SCR-300. The radio proved almost soldier-proof in the field, maintaining clear communications under conditions that would have silenced earlier equipment. Vietnam demonstrated exactly why FM radio had become indispensable for modern infantry operations. The dense jungle terrain, tropical weather, and constant presence of electrical equipment from helicopters and vehicles created an electromagnetic environment even more challenging than World War II battlefields. AM radios would have been nearly useless. The PRC-25 maintained clear communications through weather and interference that proved wisdom of decisions made 20 years earlier. General Creighton Abrams, who served as Deputy Commander and later Commander of Military Assistance Command Vietnam, called the PRC-25 the single most important tactical field item in Vietnam. Every infantry company had multiple sets. Every platoon leader and company commander depended on their radio telephone operator, the RTO, who carried the 23-pound radio on his back through jungle patrols and combat operations. The North Vietnamese army understood the radio's importance. They placed high priority on killing RTOs or destroying their equipment. A unit without working radios couldn't call artillery support, couldn't request medevac helicopters, couldn't coordinate with adjacent units. The distinctive antenna, usually the 10-foot whip carried in sections, marked the RTO as a priority target. Yet the radios kept working, kept providing the clear voice communications that coordinated everything from small unit movements to major operations. Between 1965 and 1973, the U.S. Army fielded over 33,000 PRC-25 radios to Southeast Asia. Production contracts went to multiple manufacturers to sustain the flow. The radios saw service on virtually every land vehicle, riverine craft, and aircraft that operated in Vietnam. They proved so reliable that some sets remained in operation for over a year of continuous field use before requiring replacement. The PRC-25's successor, the AN PRC-77, entered service in 1968. It looked identical to the 25 and operated the same way, but incorporated a fully transistorized design that eliminated the single vacuum tube remaining in the earlier model. More importantly, the 77 could interface with voice encryption equipment like the KY-38 Nestor system, providing secure communications when operational security demanded it. The progression from SCR-300 to PRC-25 to PRC-77 demonstrated continuous refinement of the same basic principles. Each generation got lighter, more reliable, more feature-rich, but they all used frequency modulation for the fundamental reason Armstrong had identified in the 1930s. FM provided superior performance under the actual conditions of military operations. The Cold War pushed FM technology development even further. NATO standardization agreements established common frequency bands and modulation standards so that Allied forces could communicate effectively during combined operations. Every NATO member nation adopted FM for tactical radios. The technology that had given American forces an advantage in World War II became the foundation of Western military communications doctrine. Warsaw Pact forces followed similar paths. Soviet radio development after World War II incorporated lessons learned from Lend-Lease equipment, including American FM radios. Russian military doctrine emphasized mass artillery fires and coordinated combined arms operations, both of which required reliable tactical communications. Soviet engineers developed their own FM radio systems that paralleled Western development, often using similar frequency ranges and modulation techniques. The global adoption of FM for military communications vindicated Armstrong's work in ways he never lived to see. By the 1960s, Virtually every modern military had abandoned AM for tactical radios. The technology that corporate broadcasters had resisted in the 1930s, that had bankrupted its inventor through patent litigation, had become universal, not because of marketing or business decisions, but because battlefield results proved its superiority beyond argument. Modern tactical radios have evolved far beyond the SCR-300 or even the PRC-77. Digital signal processing, frequency hopping, encryption, satellite connectivity, and software-defined. Radios provide capabilities that would seem like science fiction to World War II radio operators. The AN PRC-152, introduced in the 1990s, can communicate via FM, satellite, or cellular networks depending on conditions. It weighs about 16 pounds and provides secure voice and data transmission. Yet even these sophisticated systems still use frequency modulation for their basic radio transmissions. Modern Singers radios, which became standard for US forces in the 1990s, use frequency hopping FM to resist jamming and interception. The radio rapidly switches between multiple frequencies dozens of times per second, but each individual transmission uses FM because it still provides the best combination of clarity, interference resistance, and power efficiency. The fundamental physics haven't changed since Armstrong's time. Amplitude modulation remains vulnerable to interference from electrical equipment, atmospheric conditions, and jamming. Frequency modulation remains inherently more robust because it encodes information in frequency changes that interference can't easily corrupt. Modern radios add layers of sophistication on top of this foundation, but the foundation itself remains Armstrong's FM technology. The progression from World War II to the present day reveals how technological advantages compound over time. The American military's early adoption of FM radio in the 1940s created institutional knowledge and operational doctrine that influenced every subsequent generation of equipment. Engineers who designed the PRC-25 understood from combat experience why FM mattered. Officers who wrote tactical communications doctrine in the 1950s and 60s had served in World War II with SCR-300s. The advantage built upon itself. Germany, by contrast, entered the Cold War, having to rebuild its military communications from scratch. The Bundeswehr, formed in 1955, equipped initially with American radios, including surplus SCR-300s. German officers who'd commanded Wehrmacht units in World War II now oversaw forces using the very equipment that had outperformed their earlier radios. The institutional memory of that technological gap influenced German defense procurement for decades. Modern military historians studying communications in warfare note that technological advantages rarely exist in isolation. The SCR-300's FM technology advantage worked because American tactical doctrine emphasized decentralized command and rapid coordination. Company commanders who could reliably communicate with battalion headquarters could respond to changing situations faster. Forward observers who could call artillery corrections in real time could deliver effective fire support. The radio enabled a style of warfare that emphasized flexibility and initiative. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.